So I'm going to make another attempt here to program a 1702 and hopefully this time get it correct. I've got a couple of parts here that should be erased. So let's go ahead and power up the programmer. Make sure it's in read mode. I hate dropping the part in with the socket live, but that really is how apparently this unit was meant to be used. There's no power switch, and it says on the side on the label here to not plug it in with the part in the socket. So let's drop the part in the socket and get it in. The first thing I want to do is step through all the addresses, looking for any place where I see a 1 show up. Remember that a 1702 erases to all zeros. So if there's any bits that didn't erase, I'd expect to see a LED light up. So far it's looking erased. You may notice the address on the LED display is in decimal. Makes this programmer even more challenging. So we're back to the first address in the device. Previous video we looked at the fact that when I programmed, or the previous attempt for programming this ROM, I accidentally entered B's for D's here that are circled in these 5 locations, which is kind of interesting. I've got something under the paper that's going to irritate me. Yeah, I managed to program B's for D's in 5 places. Not really sure how I did that. Okay, what is under there? It is going to distract me. That's better. So the first thing I want to do is program this first address, F3, 3E. So there's an F3 and a 3E. I'm going to put it in write mode, and I'm going to program those 2 addresses. I'm going to put it back in read mode, and I'm going to reset and make sure it actually programmed. I learned this earlier, had a bad 1702, went all the way through the sequence and discovered nothing programmed. Just a bad part. F3, 3E. The other thing you may be noticing with the programmer is I'm programming 2 bytes at a time. It programs addresses 00 to 7F on these switches and 80 to FF on these switches. So you're really inputting 16 bits at a time and programming those 2 bytes. So let's move that up to address 1, 89A, F80. AF80, let's put it back in write mode, and we're going to program that byte, and then I'm going to move on to the next byte, D3, 890BC, D3, D3, and this is where I got B's accidentally on these 2 nibbles up here, D3, D3, let's write that, 08, 08, 08, 08, D, B, D2, D, B, D2, and load that. I'm not going to go back to read mode. I'm going to reset. I'm just going to compare these to make sure that everything's working as expected. F3, 3E, AF80, D3, D3, oops, 08, 08, DB, 8, 9, 89ABCD, 89AB, D and 2, and if we step to the next address, the part's erased. We'll go back to write mode. And it's going to be a 08, 00, 0800, E600, E, E600, 08, FB, 08, FB, C2, 22, 89ABC, that's a D, 89ABC, 2, 2, 2, 0, 1, 0, 1, 0, 1, 0, 1, FF 0, 0, FF 0, 0, 3E 7, 8, 3E 7, 8, 0, 4, 3, 2, 0, 4, 3, 2, D, again, a place I got it wrong before, D3, 0, 0, 8, 9, ABC, D3, 0, 0, 0, 9, 0, 0, 0, 8, 9, 0, 0, and address 15 decimal. We have a 1, 1, and a D3, 0, 1, 1, CD, 3. And just out of curiosity here, I'm going to go back to read mode. I'm going to reset, and I'm just going to step through again. F3, 3E, AF, 8, 0, D3, D3, 0, 8, 0, 8, DB, D2, 0, 8, 0, 0, E6, 0, 0, 0, 8. That wasn't FB, I just didn't look at it quick enough. 0, 1, 0, 1, FF 0, 0, 3E, 7, 8. Pushing the button too quick here, 0, 4, 3, 2, D, 3, 0, 0, 0, 9, 0, 0, 1, 1, D3. We're on to address 16. So we'll continue toggling switches here and see if we can make our way all the way through this. F, D, 0, 1, F, D, 0, 1, FF, D3, FF, D3, 2, 1, 1, 1, 2, 1, 1, 1, 6, 3, D3, 6, 3, D3, 4, C, 0, 5, 4, C, 0, 5, 1, B, D, 3, 1, B, D, 3, 2, B, 2, 3, 2, B, 2, 3, 1, A, C3, 1, 8, 9, A, C, 3, 7, 7, 8F, 7, 7, 8F, A, E, FF, 8, 9, A, E, FF, C, 2, 6, 5, C, 2, 6, 5, 7, D, 4, 5, 7, D, 4, 5, and that is a D. F, F, 3E, F, F, 3E, B, D, 1 0, 8 9 AB, 8 9 ABC D, 1 and 0, C2 3 1. It's a C2 3 1. Address 31. We have a 1 5 and a 7B. 1 5 7 8 9 AB. Address 32. F F 4C F F 4C D 3 F 5 D 3 F 5 2 2 D B 2 2 8 9 B C D 8 9 A B 2 F 0 9 2 F 0 9 D 3 E 6 D 3 E 6 2 3 3 F 2 3 F 3 E 0 F 3 E 0 F 2 C B 8 2 C 8 9 A B 8 D 3 C 2. Let me see D 3 C 2 2 2 0 8 2 2 0 8 3 E 4 C 3 E 4 C 0 1 1 1 0 1 0 1 1 1 D 3 7B D 3 7B 0 9 4C 0 9 4C 0 6 7C 0 6 7C 1 4 B A 1 4 B 8 9 A. Should bring us up to address 48, which is a 0 E 3 E 0 E 3 E 8 6 4 F 8 6 4 F 0 D C A 0 D C A C2 7 F C2 7 F 3 2 FF 3 2 FF FF E5, FF E5, 05, C5, 05, E5, C2, 01, C2, 01, 3, 0, 8, 0, 3, 0, 8, 0, FF 00, FF 00, C3, DB, C3, D89AB, 3F 08, 3F 08, FF 07, FF 07, D3, DA, D3, DA, D3, D89A, 09, 20, 09, 20, DB, 4C, 89ABC, D, 89AB, 4C. Well, we're halfway through. 08, DB, 08, that should have been a D, 08, 89ABC, D, 9AB. Almost made the same mistake I made before. DB, 0F, 0A, 0F, 0A, 0F, 1, 2, 0F, 1, 2, DA, 1C, 89ABC, D, A, 1C, 3F, C2, 3F, C2, FF, 20, FF, 20, E6, 4C, E6, 4C, 1, 0, 1, 0, 1E, 1, 0, 1E, 3E, 7E, 3E, 7E, 0, 2, 1A, 0, 2, 1A, C2, 7, 7, C2, 7, 7, 3, D, B, E, 3, 89C, D, 89AB, and E, F, F, C2, F, F, C2, D, B, 7, D. You see D, 89AB, 7, D. F, 09 F, F, E6, 80, E6, 80. On to address 80, 3F, 47, 3F, 47, FE 13, FE 13, 1E 23, 1E, oh, excuse me, 23, CD 0D, CD 0D. Wow. 80, 81, 82, 83, C2. Wow, how did I read that so wrong? C2, 0D. C2, 08D. Wow, glad I caught that. 4D, C2, 4D, C2, FF, 2F, FF, 2F, DB, 4C, 89AB, CD, 89AB, 4 and C, 09, EB, 09, E89AB, 0F, 4E, 0F, 4 and E, D, 2, 0C, D, 2, 0, C, 5, 6, 2, 3, 5, 6, 2, 3, F, F, A, E, F, F, 89A, and an E, D, B, B, 1, C, D, 89AB, 89AB, 1, D, B, B, 1, 09, C1, 09, C1, 0F, C2, 0F, C2, D, A, 70A, C, D, 89A, 70, address 96, 5C, FF, 5C, FF, FF, 2A, FF, 2A, E6, 7C, E6, 7C, 1F, 4C, 1F, 4C, C6, E, B, C6 E89AB, C6 EB, 107D, 107CD, for F 93, for F 93, 3E 7C, 3E 7C, 03 9A, 03989A, D3, D2, CD, 3, CD, 2, 10, 80, 10, 80, 3E, FF, 3E, FF, 1, 1, 1, 1, 1, 1, 1, 1, D3, 0, 2, CD, 3, 0, 2, 1, 0, 4, C, 1, 0, 4, C, E9, D5, E9, CD, 5, address 112, 3E, 04, 3E, 04, 04, 04, 04, 04, D3, 7, 8, D3, 7, 8, 09, B9, 0989AB, 9, E1, D8, E1, 89C, D8, F1, 06, F1, 06, 3D, 01, 389BC, D, 01, C2, C8, C2, C8, 04, 7, 8, 0, 4, 7, 8, 4, C, D3, 4, C, D3, 06, 09, 06, 09, 06, 09, 4, 3, 0, 5, 4, 3, 0, 5, 1, 1, C9, 1, 1, C9, 06, FF06 FF, for D FF, for CD FF, 37 FF, 37 FF, 37 FF. And we've come full circle. I feel pretty good about that pass. I think we may have finally got it here. We're in read mode. We can step up through and see there are bit patterns being produced. So I feel good about that. Pull the part out. I hate doing that with the power on, but it seems to be the way the thing was designed. This is at address FF00 is where it's meant to land. Let's put that in the board. Pins all look good. The notches to the left. I think we're good. So we'll go down on the computer here and we'll validate this next. So we're back down at the computer. We're looking at the schematic for the ROM board. I've actually modified this over here a little bit to allow me to select between A11 and A11 not. I have the ROM board strapped for A11, which means this is tied directly to A11 and not to the inverter. This puts the ROM board at the upper 2K of memory. The upper 256 bytes of that is the combined bootloader. And I'm going to go ahead and attempt to boot the machine from the ROM image we just programmed. So the computer's on. Let me fire up the floppy drive. I'm going to do a stop reset. I'm going to examine address FF00, and I'm just going to run it and hope for the best. And based on what I heard there, and as you can see, the machine actually booted CPM. So this is a really good sign that the ROM board is working, so I'm very happy with that. That's very cool. Of course, that ROM board is no longer being used at this point, because the machine's booted, so that ROM really is only in the address space during boot time of the machine. That ROM knows enough to be able to get the floppy drive heads back to track 0 and to read track 0, sector 0 into memory and then execute memory. It's a combined bootloader. It can boot other devices. I'm really interested in being able to boot CPM at this point, and it boots CPM. I do know I made one mistake programming it at address 112 decimal. I programmed in 3F instead of a 3E. I don't know which part of the combined bootloader that impacts. I'm going to have to program yet another device, but I'm not going to do that on camera. I've gotten what I wanted here, confirmation that the ROM board works, the ability to boot the machine from that ROM board. This completely disables the ROMs on the newer cards that I've got, the FDC Plus and the IO card, the 882 SIOP, or actually 882 SIO-JP. Those are two new design cards that I've been using to bring the system up. The floppy disk controller, is what it is. I'm going to have to just use that newer floppy disk controller. The original ones are unobtainium. I do plan to replace the modern serial card with probably a wire-wrapped version of the Altair serial card. That'll be at a future date, but after many programming attempts, we finally booted off that 72-bit ROM card into CPM, so I'm pretty excited. So with that, I will wrap this up, and we'll talk soon.